In this video, we're going to solve the inequality absolute value of 3x minus 5 is less than or equal to 4. Now, what we first want to do is set the interior of that absolute value inequality, what we call the argument, equal to 0 so that we can see, put equals 0, so that we can see where to build our number line. So we're going to build a number line here that has 5/3 marked off, and I like to put a wall down the middle. Now, to the left of 5/3, the value of 3x minus 5 is less than 0. If you don't believe me, plug in a number for x less than 5/3. For instance, the number 0. 3 times 0 minus 5 is definitely less than 0. Well, since 3x minus 5 is less than 0, then that means the absolute value of 3x minus 5 is equal to negative, round bracket, 3x minus 5, round bracket. So that means that instead of solving the inequality 3x minus 5 in absolute value brackets less than or equal to 4, on this side of 5/3, we can solve negative round bracket, 3x minus 5 round bracket is less than or equal to 4. All right, cool. So we're going to do that. Distributing the negative sign, we get negative 3x plus 5 is less than or equal to 4. We get negative 3x is less than or equal to negative 1 when we subtract 5 from both sides. Dividing both sides by negative 3 and remembering to reverse the direction of the inequality operator gives us x greater than or equal to 1/3. So on my number line, which I'm using to organize my solution, I'm going to color in everything greater than or equal to 1/3, but I have to stop at 5/3. Casually speaking, there's a wall at 5/3, but mathematically speaking, what's happening is there's a restriction that x must be less than 5/3 for this part of the solution. On the other side of 5/3, 3x minus 5 is greater than 0. Well, that implies that the absolute value of 3x minus 5 is equal to 3x minus 5. Okay, so the inequality absolute value of 3x minus 5 being less than or equal to 4 on this side of 5/3 is the same as solving 3x minus 5 is less than or equal to 4. That's like saying 3x is less than or equal to 9, which is like saying x is less than or equal to 3. Okay, so I'm going to color in that part of the number line where x is less than or equal to 3, but only the part that's in the interval that I'm currently in. If I was to get an answer here like x is less than or equal to negative 7, I wouldn't color in anything because none of that is true of the interval that I'm in. X can't be less than or equal to negative 7 if I'm on the right of 5/3. But if I'm on the right of 5/3, x can be less than or equal to 3, but only up to 5/3. So I've got an x value of 1/3 here and an x value of 3, and I've shaded those in, and I have a pretty solid solution set shaded in up there on my number line, but maybe I'm not so sure about that 5/3. Well, let's test x equaling 5/3 in the original inequality. Well, the original inequality was the absolute value of 3x minus 5 is less than or equal to 4. So plugging in a 5/3, we'd have the absolute value of 3 times 5/3 minus 5 is less than or equal to 4. 3 times 5/3 is 5, so the absolute value of 5 minus 5 would be less than or equal to 4. And that's like saying 0 is less than or equal to 4. 5 minus 5 is 0. The absolute value of 0 is 0. Well, is 0 less than or equal to 4? Absolutely. So what that means is I'm going to make sure that I've shaded in that circle up there at the 5/3 as well. And now what I'm going to do is I'm going to state one solution set for my answer. My solution set is the set of all x element of the reals such that 1/3 is less than or equal to x is less than or equal to 3. And since the question asked for it in interval notation as well, I'll put it in interval notation as well. All right, so hopefully you enjoyed that video. got something out of it, and I'll stop recording.